Yeah, he can. Yeah, thank you.
Hello. Good morning to everybody. Can you hear me? Hello, yes. And now today, very important concept, but not a difficult, easy. But so many others are not writing about why exist operator performance is very high compared to in operator. Properly not writing. That's a problem. But easy concept. And now here, whenever interview asking a number of person or databases also same answer, same. In versus exist operator. Yesterday, I am telling only one query. I am writing only exist operator. Query is difficult. Yes, correlated subquery. Display those departments from DEPT table having employees in EMP table. I am writing. Okay, this is the query. Exist operator through we are writing correlated. Then 10, 20, 30 it will display. Again, recently we are writing a what? Which one? Yes, very good. Non-correlated subquery in operator. Very easy query we are writing. That is a non-correlated subquery, but easy query. Whenever we are using a what, that query also same output it will be retrieved. But in a project side, which one is preferring exist operator with correlated only, preferring a what? Whenever we are testing a one table, column values are available in another related table. Not all the cases, in this case only. One table column values are available in another related table. 100% they are using a correlated subquery exist operator. Why? Because in that case only that subquery. So now here, yes, performance is very high compared to where? Non-correlated subquery in operator. Why? Any reason is there? Yes, the reason is very simple. Reason is most powerful. And now concentrate here. And now everyone concentrate 5 minutes. Through the diagrammatical also I will tell you. Okay, what is the reason behind that one only? Whenever we are testing a one table column values are available in a where another table, only real-time project side. Correlated subquery exist operator only. Why they are preferring? Why they are not preferring a non-correlated in operator? Today I am telling. Very easy. Suppose simple technique is there. Actually, in operator, how you are writing the queries? Generally, suppose first initial stage you are familiar or not. Now check it out. Concentrate here. Select star from EMP. Where where department number in only 20th department, now 30th department, 50th department, like this only I am telling, no, 10 comma 20 comma 30 comma maybe now here again 40 comma 50 comma 60 comma 70 comma 80 comma 90 these type of queries you are writing first initial stage or not? Yes, here. Now slowly observe it here. So now here, yes, here. Now check it out. Concentrate here. Concentrate here. And now here, concentrate. Suppose, and now observe it here. Whenever we are using a what in operator, how it will be searching by the server means it will check a what each and every value. It is used to pick the values one by one from list of values. Department number is equal to 10 also it will be checking. Department number is equal to 20 also checking. Department number is equal to 30. It will pick the values one by one values from list of values. Already have an idea or not? Department number is equal to 40. Department number is equal to 50. Department number is equal to 60. Department number is equal to 70. Department number is equal to 80. Department number is equal to 90. Observe it here. Here, how many values are there? 9 values are there. All values are checking or not? Yes, that's why in operator checks what? All values. Oh, maybe something logic is there. All values it will be checking. Whether condition is true or false also, every value in the list also it will be checking. All values in checking by the where server. But unfortunately, exist operator not like that. Exist operator checks what? Some values only it will be checking. There is a difference. Some values only it will be checking. All the values does not check. Millions of records are available also. Some values it will be checking enough. What is going on? What is this one? Yes, how you are understandable means concentrate here. Suppose I am writing a what query, non-correlated subquery, this one. Don't write it, just observe here. This is non-correlated subquery. This is a logic. First observe here. This example through we are learning non-correlated subquery. Whenever non-correlated subquery in operator already have an idea. What is the query? This query have an idea. Okay, fine. Yes, concentrate here. This query have an idea. Non-correlated subquery. Yes, this one. Again, correlated subquery is there. Correlated diagrams I'm drawing only. Correlated subquery. Difference observe it here. Correlated subquery. Yes, you have an idea. This query you are writing only in a yesterday class. Okay, fine. One table column value testing in aware, another table. Slowly observe it here. Diagrammatically very interesting, easily understandable. Suppose is a non-correlated subquery means one table column values testing in aware, another table, how it will be executed, what happened means, observe it here, concentrate here. This is a non-correlated subquery. Suppose here, this is a what? Child table. Observe it here, this is a child table. This is a child table means subquery EMP table only, this EMP table. This is a EMP table. Here some data is there. For example, department number is a column is there. Slowly observe here. Department number is a column is there. DEPT number. Now in this department number column, so many department numbers are there. For example, now here suppose here now 20 is there. Here 10 is there. Here 30 is there. Again 20. Again 10. Again 30. Anything. Okay, fine. Yes, here. Again here 10, again 20, again 30, like this. So many departments are there, millions of records. But what happened, how it will be executed, what in operator we are using means parent query table, you have an idea or not? Yes, in a parent query table, first row, for example, for a department DEPT table, department number is equal to 10, for example, department number is equal to 10. How it will be checking means internally, how it will be checking means observe it here. 10 is equal to 20, matching or not matching? Yes, here every record it will checking. 10 is equal to 20, matching or not matching? Okay, so no, not matching. That's why this record is checking. Slowly observe here, this record is checking. Again, 10 is equal to 10, matching or not matching? Matching. This record is checking only. And now here, this is match is found also. Yes, it does not stop the execution. Remaining records also it will be checking. Again, 10 is equal to 30, matching or not matching? Not matching. Again, 10 is equal to 20, matching or not matching? Not matching. Again, 10 is equal to 10, matching or not matching? Matching. Again, 10 is equal to 30, matching or not matching? Not matching. 10 is equal to 10, matching or not matching? Matching. 10 is equal to 20, matching or not matching? Not matching. 10 is equal to 30, matching or not matching? Yes, not matching. That's why I observe it here, observe it here. Whenever we are using any relational database system in the worldwide, whenever we are using a non-correlated subquery in operator, yes, in this example side, if DEPT table department number is equal to 10, I am giving, we'll see all the department numbers in EMP table, whether match is found or match is not found. Whereas in a correlated subquery, not like that. So now in a correlated subquery, not like that only, different execution. Now check it out here, check it out. All records it does not check. Suppose correlated subquery exist operator is there, totally different execution. This is important. This diagram you have an idea means then theory I will tell you. Now check it out. Concentrate here. Suppose here in a correlated subquery side, how it will be executed means, suppose here, this is a what? A child query table is there? No? Yes. Here totally different. Concentrate here. Now, this is I want only. This is a child query table. For every row in the parent query table, child query is executed or not? Yes, here. Now check it out. DEPT number. Now concentrate. Diagrammatically, everyone understandable, very easy. So this internal concept. Now check it out. Here, what is the department number is there in EMP table? For example, 10, 20, 10, 30, again 20. 10, 30, okay, anything, okay, 10, 20, 30. For example, these are the department numbers are there. Now, parent query table is which one? So now 4 rows are there, no? Yes, 10th department, 20 department, 30 department, 40 department is there, no? Yes, it will get a candidate row. So now the DEPT table is there or not? Yes, a DEPT table is there. In this DEPT table, candidate row, first row, 10th department is there or not? For example, for first row, how it will be checking, observe here. For DEPT table, for candidate row first one, for DEPT table, department number is equal to 10. How internally it will be searching means, observe it here. 10 is equal to 20. Matching or not matching? Very good. Not matching. Match is not found. Okay, fine. Not matching. Again, 10 is equal to 10. Matching or not matching? Very good. Matching. At least one match is found. At least one match is found. Yes, it exists. Operator returns a what? Which one? True. In this case, yes, control does not goes to remaining records. Remaining records does not check. That is the beauty of the where exist operator. At least one match is found, then this condition is true, then automatically this candidate row return into where result. In this case, it does not check remaining number of records. That's why millions of records are always checking in a where in operator side. In a child table, more number of records are there, means all the records are checking in a previous case in operator. But in this case, how much simple logic? This is so many fellows are doesn't know. It does not check internally. It does not check. It does not check remaining records. Remaining. So now here, yes, remaining. Now here it does not check remaining. Now here remaining number of records. Remaining records. Now here, yes, whenever condition is true, whenever at least one match is found, yes, it will stop the execution process. That is important in that phase side only. Stop the execution process in that okay, so now here at that phase. Suppose the second row means department number is equal to 20 is there, no? Yes, second row. For parent query table, second row, 20 is equal to 20 matching. Whenever at least one match is found, these all the records does not check. Yes, here how much easy. And whenever this is a condition is true, then this candidate row return into a result or not. Yes. Again, department number is equal to 30, parent query 30 means 30 is equal to 10, not matching. 30 is equal to 10, not matching. 30 is equal to 30, matching is there or not. If at least one match is found, then remaining number of records not so now checking only. In this case, true, then that candidate row it will be written. But fourth record is a 40th department is there or not. In this case, it will be checking. As observed here, 40th department is there. In this case, 40 is equal to 20, not matching. 40 is equal to 10, not matching. 40 is equal to 30, not matching. 40 is equal to 20, not matching. 40 is equal to 10, not matching. 40 is equal to 30, not matching. 40 is equal to 10, not matching. 40 is equal to 20, not matching. 40 is equal to 30, not matching. That's why in this case, in a last record case only in this example, all the records in a where in a BMP table side, it will be checking or not. Yes. But in all this scenario, previous case in a 3 record side only, 1 or 2 records are matching. At least one match is found. It does not check remaining number of records. That is the beauty of the where in exist operator. That's why exist operator gives a more performance, because each and every time millions of records are here. Here 10 or 20, 30 means not a problem. That exist and in operator performance is not a biggest problem. But here millions of records are there in that case only. That's why always in the second example side, correlated subquery side, if DVPT table department number is equal to 10, founds at least a single match, then exist operator returns true, and also database server does not check remaining number of records in EMP table in this case. That's why in this process, database server checks less number of records in EMP table for each and every candidate row in a where DEPT table. That's why in this case only exist operator gives more performance than the in operator. That's important. How much easy? That's why in a in operator, all the records are checking, but exist operator, all the records are never checked. At least one match is found also. Yes, here that candidate row return into where result. Very good. And now first observe it here. First this example, write it. Then theory I will tell you. Okay. Yes, here that theory notes through your understandable. Just write it fastly. In versus exist operator. First non-correlated subquery fastly write it, yesterday query. This diagram, write it. Non-correlated subquery, write it. Here you have an idea output. Now output I am not writing 10, 20, 30 or not. Yes, here. In this case, fastly write it this diagram. Draw this diagram only. Here child table, EMP table. Fastly write it. Here department number. Then I will tell you exist operator in a very different way also. This query write it, and in operator side, this diagram draw this one. Diagrammatically means easily understandable. Here 20, Yeah. Any number of records, don't worry. Okay, yeah. For easiness purpose, for DEPT table, department number is equal to 10, all the records. Department number 20 also, all the records. Department number 30 also, all the records like this. Okay, na? Yes, example, this one. For DEPT table, department number is equal to 10. Here, it will be searching about all the records. That is important. Whether match is found or not found. Here, all the records searching like so only. Easiness purpose. Or maybe it will be checking internally all the records only. That's why database administrator testing your performance whenever one table column values, related values are available or not available. Exist operator only less more performance than they were in operator or not. In this case only, not all the cases. All the records are checking. Just draw this one properly. That theory easily understand. Finished. Faster draw this one. Non-correlated subquery. This example, write it. This query, write it. Select star from DEPT where department number in yesterday. Select department number from EMP. In that example side, draw this diagram. For DEPT table department 10 means all the records, 20 means all the records, 30 means all the records, 40 means all the records, it will be checked. Internally, searching all. Server is searching. It is not visible anything. Okay, now fast. Completed. Take a snap. Okay, enough. Finished. Next, ready. Correlated subquery. That one, write it. And also draw another diagram. Yes, your. Now correlated subquery, write it. This subquery, write it. Only diagram through you are telling only very easy. Interviewer asking is easy. Here also output is same, no? Output is same, but internal searching is different. For each and every candidate row in a parent query table, that it internally searching in aware, all the records in aware in operator. But here only up to match is found, that will be searching. Remaining record not searching. Okay. Yes, very good. Now this now correlated subquery exist operator. This one, write it. Draw this one. Fastly write it. This query. Now this diagram also write. Draw this diagram. This is a child table. EMP table. For example, DEPT number is a column. In a records also draw this. Anything, don't be. Any records, just draw. Here, first candidate row, I am drawing only enough. For DEPT table, department number is equal to 10. Internally, okay? Na? If department number is equal to 10 means not matching. Here, 20 is equal to 10 is equal to 20, not matching. But here, 10 is equal to 10, matching. At least one match is found. Yeah, in a first candidate side. Here, automatically it will return what? True. Whenever at least one match is found, it will return what? True. Whenever this condition is true, it stops the execution process. Stop the execution process means that candidate row internal searching. Okay, yeah. Stops execution process. Execution process of that candidate row. Internally. Whenever condition is true, control does not goes to where? Remaining records? Yes. Here, it does not check, right? It does not check. It does not check. Remaining number of records. records. Remaining number of records, it does not change. Not only 10th department, 20, 30, 40, like this each and every time. Okay, na? Write it faster. Draw this diagram. Simple. Internal concept. Then not in versus not exist also same thing. But another null value side I will tell you. Then we can also use exist operator on a single table, I'm telling. Then non-correlated subcore is also I tell. Then only special operators in all NA is there, no? Subcore is special operator, multiple column subcore. Complete fast. This correlated, this diagram, draw this one. Otherwise, take a snap fast. Okay, write it some theory. Finished fastly. It does not check remaining number of records. Okay, yeah. Completed. Not only 10, 20th department next, 30th department next, 40th department, each and every candidate of the parent query table internally searching or not? Yes, at least one match is found, stop the execution, then returns true. Non-empty set, empty set, yesterday we are telling no, yeah. Write it, some theory, write it, very important, most powerful. Not all the cases, anybody interview asking is be careful. Whenever one table column values are available in another table, in that case only exist operator performance is very high compared to where in operator. Otherwise, nobody gives the guarantee. Okay, yeah. So now you write it fast. Next para. In all relational databases, in all relational databases, in all relational databases, exist operator gives more performance. Exist operator gives more performance than the in operator when we are testing one table column values are available in another related table because each and every time exist operator does not check all the records, example, write it, example. Now here, what is example? Actually, in a previous case, this example is there, no, non-correlated, correlated. That example through I'm explaining because one table column values, another table, no, yeah. Write it example. In the above example, above means previous case we are trying diagrams, no, that one, write it. In the above example, whenever we are using non-correlated subquery. Non-correlated subquery. Non-correlated subquery in operator. In non-correlated subquery in operator. Then if DEPT table department number is equal to 10, if DEPT table department number is equal to 10, we'll see all the department numbers, all department numbers in EMP table, whether match is found or whether match is found or match is not found. Match is not found. Whereas in correlated subqueries, exist operator, whereas correlated subqueries exist operator. Whereas in correlated subquery exist operator. If DEPT table, example side, if DEPT table department number is equal to 10, founds at least a single match, at least a single match, 10 is equal to 10, 20 is equal to 20 is there, at least a single match, founds at least a single match, then exist operator, returns, true, and also database server, even database server and also database server does not check remaining number of records in EMP table. In EMP table means style table, EMP table. That's why in this process, database servers server checks less number of records in EMP table for each and every candidate row in DEPT table. Sorry, each and every row, every candidate row in DEPT table. That's why in this process, that's why in this process, sorry, that's why in this case only, That's why in this case only exist operator in this case, right? That's why in this case only exist operator gives more performance than in operator. Exist operator gives more performance than in operator. That's why anybody interviewer asking about how you are given the guarantee exist operator gives more performance than in operator. You are not administrator, you are a developer, you doesn't have an idea in a performance tuning concept. But how you are given the guarantee means through these examples you are telling. One table column values testing in a way, another table, related table, then only okay you are telling like. But unfortunately, in a Java, .NET, Python, these programmer means this much of knowledge is not there. That's why they're giving you one chance. Okay, you are unable to tell in operator and exist operator reference. Yes, what is the difference between not in or not exist? They are asking only so many interviewers. Why? Because not in versus not exist means same execution side, same performance only. But not only that one, in a real-time project side, we are not in queries where one table column values converted into variables, so we are searching and where another table column values means in place of not in, not exist, we are using. Okay, really, I'm agree. But unfortunately, you are a front-end developer, so maybe Java, maybe .NET means this much of knowledge is not there means simple technique is there. What is that one? What the difference between in and exist means there is no choice. But not win versus not exist means one choice is there. You don't know performance tuning also. You don't know this internal concept also. Some other concept is there. Not in versus not exist. What is that one means? Whenever not in operator we are using means, then automatically not in operator does not work with the what null values. First initial stage I'm telling or not. Does not work with the what null values. Whereas not exist works with the what null values. That is I want. So now here in all relational databases, not in operator does not work with the null values, whereas not exist operator works with null values. Very, 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 very important that one. Now here, then only single table and non-correlated, those all the things I will tell you in a way exist on all this. Write it. Write a query. Is very easy. Write a query. Write a query to display those departments write a query to display those departments from DEPT table does not have employees in EMP table by using non-correlated subquery. By using non-correlated subquery. By using non-correlated subquery. Non-correlated subquery means not in operator, no. And now here, check it out. Suppose here, this is a DEPT table is there. Very easy. Now simple. In this DEPT table, only 40th department details are not available in EMP table. You are observing or not in EMP table, this 40 is not there. That's why display those departments. Those departments does not have employees in EMP table. Those departments only I want means just we are using a what? Not in operator. Not in operator. And now how can I don't write it 1 minute only? Select star from DEPT. Yes, here where department number, not space in. Here we are using a what? Select a department number from EMP. This is everyone knows. And now here, yes, here 40th department. And now here, check it out. 40th department only. So now here, yes, here it will be displayed as a what? Now here, check it out. Here it will be displayed the what 40th department. Now check it out. 40th department operations and Boston. This department details are not available in employees only. That is displayed, okay. But unfortunately, suddenly in a project side, you are inserting a null values in a where in this department number. Suppose EMP table is there. Select the star from EMP. In this EMP table, one null value is there. For example, maybe now up to today, correctly working also that query, just maybe another programmer just there some other purpose on a null value, one null value they are inserting in a where in a DEPT number column. Suppose here insert into table name EMP, here employee number, comma E name, comma department number, for example, here values, here one, my name I'm inserting Murali. Now here, yes, department number null I'm inserting. For example, okay, fine. Whenever one null value is there, now check it out, select a star from here, EMP, sorry, now here EMP, one null value is there or not? Here, one Murali is there. Here, department number is a what? One null value is there. Now I want to display those departments from DEPT table having employees in, does not have employees in EMP table means how we are writing, select a star from DEPT where department number here not space in here select DEPT number from EMP. It won't work. Already I'm telling anybody attending a special operators means in that class first initial stages not in operator does not work with null values. What is the reason behind that one? Not in operator we are using means internally and operator is there already I'm telling or not. That's why not in operator does not work with the what null values. This is a dangerous mechanism. That's why no row selected. But these type of problems are never occurred in a where in a where yes not exist operator with the correlated subquery. Now check it out. That's why technically performance okay, but technically also that's why not in and not exist. This is another advantage is there. Suppose you are a good experienced person means now here you are using a what so now if not exist operator instead of this one means there is no problem. Select star from DEPTD where now here not exists here only we are using a what select star from EMP where department number is equal to D dot department number because alias name we are using no yes here in this case null values are available also it will be working or not. That's why not in operator does not work with null values whereas not exist operator works with what null values. Why we are not using a what NVL and is null in a where in a real time project side in a where in this case not in operator side means that is working also they are not using means yes performance is very low. Why? Because indexes it does not change. Index is a chapter is there in a feature you are understandable whenever is null operator is there is not null operator is there those queries does not check what searching a what indexes now here that's why performance very low. Okay. Now at least that much of knowledge you don't have an idea also this one we are writing only now here now check it out. First this query write it. This query write a query to display those departments from DEPT table does not have employees in EMP table by using non-correlated subquery. Then you are inserting a what null values. Checking purpose. Because not in operator does not work with the what null values. No, that's why not exist. There is no problem with the what null values and all these things. Why? Because true and false based only working or not. Yeah. Okay, na? This null value after just again that query, right? That is no row select. Write a note. Finished. No row selected. No. Write a note, right? In all relational databases, not in operator does not work with, not in operator does not work with null values. Whereas not exists operator work with null value. Solution, right? Okay, exist operator, not exist. NVL is null, is that's the performance difference only, that's all. This theory, right? Okay, na? Up to this one is enough. Another class is there. Up to this one is enough. Tomorrow I will tell you remaining. Tomorrow will continue. Remaining tomorrow will continue.